Alright, ways 2 and 3 are substitution and elimination. Substitution, here we go. Do you agree with this? Everybody copy this down. So we're going to start with a very beginning building block. 5 plus 2 equals 7. Write it down. So do you agree 5 plus 2 is 7? So they're equal, right? 5 plus 2 is the same as 7. So what if I've got this? If I've got 3 plus 7 equals 10. Here is the idea of substitution. Alberto, you're going to take two things that are equal. I know that 5 plus 2 is the same as 7, right? So anytime I come across a 7, I am going to substitute in place of 7 something that is equal to it. I'm going to substitute 5 plus 2. So I'm going to rewrite this whole problem as 3 plus, I'm not going to write 7. I'm going to substitute what is equal to 7, which is 5 plus 2 equals 10. So now look what I got. My original statement was 3 plus 7 equals 10. And now I've got 3 plus 7 equals 10. But I don't have their 7. I swapped them out. I substituted a different 7 for the 7. Does that make sense, Ray? You see how that's a legal move? Well, you can, but look, do you see that? Am I legal? Am I okay? It's okay. This is something really basic, but it's going to get kind of funky. So you just got to understand and agree that we're legal. Alberto, we legal? So we can trade them? Okay, let me erase this. Let's give you elimination. Write this one down. 5. 5 plus 3 equals 8. And then write this one. 6 minus 4 equals 2. Okay. You got two true statements, right? 5 plus 3 equals 8. 6 minus 4 equals 2. You combined them horizontally. You simplified 5 plus 3 equals 8. 6 minus 4 equals 2. Shania, if you stack them on top of each other, you can also go vertically. So let's add them. What is 5 plus 6? 11. What's 3 plus a negative 4? So 11 plus a negative 1 equals 8 plus 2? 10. So look, I started at the top with the true statement. I started on the bottom with the true statement. And you can add them vertically, and you will end up with 11 plus a negative 1. You're going to end up with the true statement. So this way is called stacking. I call it stacking. You're going to line them up. You're going to add them vertically. This way is elimination. So are we legit? Is that an okay move? Okay, let's do some substitution. First of all, solve these guys. Go. Okay, circle this. These guys are special cases. These are special cases. These are weird. These are not your everyday equations. These are kind of weird. This first one right here. Clean up this right side. Combine your x's. 7x's minus 5x is going to be 2x. And then combine your constants. What's minus 1 plus 5 plus 4? Now, what do you have on the left? 2x plus 4. What do you have on the right? 2x plus 4. You got the same equation on both sides. Look, if we minus 4, you're going to have 2x equals 2x. If you get your x's on the same side, if I move these x's over here, minus 2x, minus 2x, you got 0 equals 0. Is that what you ended up with? Okay, these are either true or else they're false. 0 equals 0. Is that true or false? True. Circle it. Box it. If you get an equation that ends up weird but is true, your answer is this: all real numbers. That means no matter what you plug in for x, you're going to get the same on both sides. Look at this. On the left I had 2x plus 4. On the right I had 2x plus 4. So if I drop x is 10, if I put 10 in for x, they're both going to give me 24, right? If I drop 100 in for x, they're both going to give me 204. So I can drop anything in for x, and it's going to make both of them the same. So all real numbers. Now this one right here is also a special case. It's kind of weird. Distributive property first. 3 times x is 3x. 3 times the negative 4 is a negative 12. Plus 2 equals 3x minus 12. Combine your terms here. So 3x minus 10 equals 3x minus 12. Let's get your x's on the same side. Let me take these 3x's over. Minus 3x minus 3x 0, 0. So you got a negative 10 equals a negative 12. That's weird. Is it true or false? Or you get 0 equals negative 2. You get something. As long as your something is false, right? What does false tell us? False tells us there is no solution. There is nothing. This is not a, they're not equal. They are not equal. You cannot put something in for x that's going to make them equal. So they gave you a trick question. They gave you something that is not equal. Now, if you get false, Irving, or you get no solution, think of a system. What kind of lines are you looking at as far as a system? If you get no solution or you get false, what are you looking at? Ray, write it down. This guy right here is going to give you parallel lines. Okay, what about the all real numbers?
It'll be like on top of each other.
It's going to be the same line on top of each other. Same line on top of each other. Okay? So if you get a true statement, you're looking at the same line on top of each other. If you get something false, that means they're parallel.
Would it be like two different lines on top of each other?
Yeah. Okay, look. Substitution. You guys take a breath. Right? Of the 3 ways, this is probably the hardest. This is abstract. At first it's hard to catch the vision. But once you catch the vision, it's not too bad. Okay, substitution. This is when we use it. You use it when you have an equation that has a variable all by itself. I mean this right here. The y is all by itself. Okay, this other guy is in standard form. Y is all by itself. So y is the one we substitute. Is the variable we substitute. Whatever's alone, that's what you're going to swap out. If x was alone, that's the one we'd trade. So since y is alone, that's the one we're going to trade. Nice try, Jake. Here we go. Are you ready?
Actually, I got it.
Did you kill it?
I was like, man, did I get it or not?
Jake, kill it. Y is a negative 2. Circle this. Negative 2. What are we going to do with that negative 2? You are going to drop it in place of y on the other equation. Because this top y and this bottom y are equal. They're the same thing. So I can trade it. A 7 for a 7, right? I can trade a 5 for a 5. They're equal. So here we go. This negative 2 is going to be dropped in right there. So watch this. You're going to copy and paste 4x minus 5. What's the 5 doing to the y? Plus, minus, times, or divide? It's times, so I'm going to do parentheses. 4x minus 5 times y, but I'm not going to put a y. What am I going to put? I'm going to put a negative 2 because I'm going to trade them out. Equals negative 18. Now what that allows you to do Is this just an algebraic equation? Solve it. Go. What's a negative 5 times a negative 2? So you got 4x plus 10 equals negative 18. Solve for x. Minus 10 minus 10. Do you have 4x equals a negative 28? Divide by 4. Divide by 4. What's x? X equals a negative 7. If you know x is negative 7, how can you find y? Yes, x is negative 7. Take that negative 7 and substitute in for x. You're just going to plug it in. Now plug it back in. This says to do 4 times x. If I know x is a negative 7, what is 4 times a negative 7? 4 times a negative 7 minus 5y equals negative 18. So 4 times a negative 7 is a negative 28 minus 5y equals negative 18. What do we do first? We got to get y out by itself. Irving, put it on my desk. Do you get rid of the negative 28 or do you get rid of the negative 5? So plus 28 plus 28. What's negative 18 plus 28? Negative 5y equals 10. Divide by negative 5. Divide by negative 5. What is y? Y is negative 2. So your answer is this. X is negative 7. Y is negative 2. So you found it. This is where they cross. You found it without graphing. You found it only with algebra. So
Seems faster.
graphing seems faster. Yes. When are you going to use this? Use the algebra when you got some funky equations, decimals, fractions, numbers too big. Graphing is going to be faster and easier on some, but some it will not. Okay, let's try this one.
So you don't need to put y in 7.
No, you don't. Substitution, here's when you use it. Okay, look at your two equations. Shania, this y is all by itself, right? And this bottom one is in standard form. So that's your hint. I'm going to use substitution. Substitution is going to be slick. Are you ready for substitution? What is the same as y? 4x plus 4. So here's what you're going to substitute. You're going to substitute 4x plus 4 where you see the y. So this 4x plus 4 is going to be swapped in right there. Okay?
So if you times a negative 2 like 4x and stuff, is it negative 2 or is it just 2?
Negative 2. That's a good question. Okay, here we go. Copy this. 8x minus 2 times y. So I'm going to do 2 times y. But I'm not going to put y. What am I going to put? I'm going to put the same thing as y. This is just a y in disguise. 4x plus 4 equals a negative 8. Now Mallory's question. In the parentheses you got two things. Shania, you need to times both of them by this 2. But the 2 is negative. So you have to include the negative or else you're going to get the wrong answer. So bring this 8x down. Bring 8x down. Put a plus. Okay, the negative 2 needs to be multiplied to 4x. What's negative 2 times 4x? Negative 8x. Negative 2 needs to be multiplied to the 4. What's negative 2 times 4? Negative 8 equals negative 8. Okay, clean up this left side. What's 8x minus 8? 0. So you got a negative 8 equals a negative 8. That's something weird. That's a special case. Is it true or false? That's true. So that means, are these lines your options? is this a parallel system, or is this the same line on top of itself? Same line on top of itself. So your answer is infinitely many solutions. Same line on top of itself. Infinitely many solutions.